We've come a long way to get to where we are in reactions. If you think back to the very beginning of the year when I just showed you what an element and an atom were, and now we fast forward all the way to the point where we know that reactants react together. You hit an arrow, your yield sign, to form products. And we've done numerical comparisons, stoichiometry, on how to calculate, well, if I have this much reactant, I can make this much product. We're going to take a step away from numbers, but still focus on reactions and start classifying the reactions themselves. There's different types of reactions based on what's reacting together. And we're going to go through those different types. But before we get to those lectures, I want to look at reactions more generally in regard to something that we call translating, being able to turn words into formulas. Now, this may sound familiar because back in November and December, we did this. We got really good at it. But now there's some new little things that'll happen when we're putting them in reaction form, some new little words like what word means plus and what different words can mean the yield sign. So I'm going to show that to you today. But it's also going to really call back to our nomenclature skills on looking at prefixes for covalent molecules or crisscrossing charges for ionic compounds. So, new unit, focus. If you look at your new cheat sheet, you'll notice that I've supplied you with a polyatomic list. It's the same list that we used last year or last semester, but there it is on your cheat sheet. I had space, so you don't have to flip on the back of a periodic table now. But if you look at the very top section, it says, how do I translate a reaction? That's where we will be working today. But before we start translating, and by what I mean by translating is we're going to take words and turn it into compounds. All right, sodium chloride is NaCl. That's all it is. There's a few things that we need to remember. First off, diatomic molecules. We mentioned them back in December, but there's 7 elements on the periodic table that can't exist by themselves. If you remember, on the periodic table, I showed you kind of a Tetris shape that goes like this, that lists the majority of the diatomic molecules. If you put your finger on nitrogen and slide it over to fluorine, and then slide your finger straight down to chlorine, bromine, and iodine, you'll hit 6 of the diatomic molecules. Who's the other one? Hydrogen, all right, my buddy way up here. Remember, all that was meant by the fact that we described these 7 elements as diatomic is that they can't exist alone. If they try to, if oxygen's all by himself, what did we have to give him? A second oxygen. O is always like that if he's not bonded. He's O2. So fluorine, since he's also diatomic, is F2. But if I give you sulfur, sulfur can just look like that. Sulfur can exist alone because he's not a diatomic element. And that's just the nature of the elements in regards to how they live on our planet. You can find one sulfur atom, but you can't find one fluorine atom. It'll either be bonded to something or bonded to itself. Being familiar with my 7 diatomic molecules is essential for the skill that we'll do today for translating. So they're listed there on your cheat sheet, but some people like to draw like a darkened box around it on their periodic table. Do whatever you want to do so that the diatomic molecules jump at you. For some additional vocab, this situation where elements do try to exist by themselves, we call those free elements. If an element's not existing by itself, it's a compound, where there'd be multiple capital letters jammed together. So again, there's 2 different things that we'll run into in the sentences that we're about to translate. Free elements, elements that are trying to exist alone. Sometimes they'll be diatomic, sometimes they won't. Or compounds, where we've got Na and Cl together, or hydrogen and oxygen together. More than one capital letter. So with that said, let's take a look at our first translating problem. This will be our first problem. You can pause the video and write down the sentence. Here's our job when translating. every part of that sentence is going to tell us to write something. And we just have to carefully turn every English word into a chemistry symbol. Now, there's some special symbols that we know that show up in our equations, like plus signs and arrows, yield signs. If you look at your cheat sheet, I give you a small list of things to look for that indicate this. It says the words and reacts with both indicate a plus sign. It says that phrases like yield, to produce, creates, reacts to form, or creates will indicate a yield sign. So with that cheat sheet in front of you, it can really help us with what we're about to do here. So, looking at the sentence you just wrote, lithium. What do you think I write for lithium? Li, perfect. All right, lithium is Li. Reacts with. Yeah, that's a phrase, and you'll get, as after practice comes, you realize sometimes it's one word will equal one thing, and sometimes it'll be a phrase that'll equal a thing. Reacts with. Look back at your cheat sheet if you don't know what symbol does reacts with. It's a plus. It was one of the examples that indicates a plus sign. Nitrogen. What do you think nitrogen is? N. Perfect. Brain surgery, right? Here comes another phrase. To produce. A yield sign. All right. And those of y'all that are like, how did you know that? Look at your cheat sheet. To produce is under the list of things that means an arrow. Lithium. Li. Nitride. Now look here, look here. Notice how there was nothing between the lithium and the nitride. Here, there was an and, or a reacts with, or there was words in between the lithium and the nitride. But on the other side here, there is nothing between them. Whenever the element names are jammed together, the symbols need to be jammed together too. So lithium nitride is lithium nitride. It was building a compound. So there it is. Lithium reacts with nitrogen to produce lithium nitride. We did everything we were supposed to do, but we're not done. Here's the part that will mess you up if something's going to mess you up. After you've translated everything, you have to go back and check everything you translated. And here's what you're looking for. For every free element that you wrote, you need to ask yourself a question. Must be not using arrow. You need to ask yourself a question. Is it diatomic? But also, for every compound you wrote, you're going to ask yourself a different question. You're going to ask yourself, are the subscripts right? All right, so with this in mind, with these questions in mind, we're going to go piece for piece through our compound and just ask ourselves those questions, and then we'll be done. So here we go. Look at him. Look at that guy right there. Is he a free element? Remember, a free element means an element existing all by himself. Or is he a compound? Multiple elements jammed together. What is he? He's a free element because he's all by himself. So what do we ask ourselves when he's a free element? Is lithium diatomic? No reason to guess. Is lithium diatomic? No, remember, go back. Some of y'all are staring at me. Go back. There's 7 diatomic molecules. It's a tetra shape plus hydrogen. Is lithium one of those 7? No, he's not, which means lithium is fine, because lithium can exist by himself. So we can leave him alone. Let's go over to this guy. Is he a free element or a compound? He's all by himself. Nitrogen's all by himself. Must be a free element. So what question do we ask ourselves? Is he diatomic? Is he? Nitrogen is on our diatomic list. What do we have to do to elements that are diatomic? Got to add a 2. Let's move to this guy. Is this guy a free element or a compound? He's a compound. Multiple elements jammed together. We don't care about diatomics when he's a compound. All right? It's a totally different world when it's a compound. We ask ourselves, are the subscripts right? in order to check, in most cases, you need to check charges in crisscross like we did yesterday. That's why we did that yesterday. But if there's prefixes like mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, then we wouldn't have to crisscross charges. The subscripts would come from those. But that's not the case here. It's a compound, so let's check the charges. What's lithium's predicted charge? It's a +1. What's nitrogen's predicted charge? It's a -3. If the numbers are different, they crisscross. So I want the 3 to go to lithium and the 1 to go to nitrogen. We said the 3 is going to go to lithium, the 1's going to go to nitrogen. We don't show 1's. And now we're finished with our first problem. If your periodic table is missing those charges, let's make sure that it's not. Add this if you need to. All right. What I'm writing in black right here is the group numbers, the columns. 1, 2, 13, 14, 15, 16, 17, 18. Above those groups, above hydrogen, you should have a 1. Above beryllium, a 2. And then it goes like this. Make sure you have those charges. You've got to have those in order to survive our translating. Yeah. Now realize, even though we're going to quit here because we want to just practice translating, we're not done. What's wrong with that reaction now? It's not balanced. So you'd have to go and add coefficients and have more fun, which is why balancing is a cornerstone of chemistry. But we have translated. Let's do another problem. Here's our second example. So in regard to this translating, you kind of just want to get your brain into two different zones. First, for every word, you're going to write a symbol. Then you're going to go back and check what you wrote. So let's do it again. Lead. Help me out. PB is lead. Hopefully you're quiet just because you're quiet. We all know that lead's PB, right? Now, there's a Roman numeral 2 there. The Roman numeral 2 has no bearing on this part. It gives us a charge. If you remember, the whole point of Roman numerals was to give you charge of these transition metals that we don't know the charge of. So for this part, we don't need the Roman numeral 2 to continue, but he'll be important when we go back and make sure our subscripts are right for this compound. Sulfate. What's the symbol for sulfate? It's SO4. If you look at your cheat sheet, you've got a polyatomic list again. Verify that sulfate is SO4. Yields. What do you think I'm going to put for yields? An arrow? Lead. What will I put for lead? PB. There's another Roman numeral. It's important, just not for the first step of my translation. Sulfite. What's the symbol for sulfite? SO3. Verify on your polyatomic list. And it's a plus sign. Verify on your cheat sheet. It's on your list of things that mean plus. So don't overlook the word and. Oxygen. Oh, thank you. There we go. We've done the first step. For every word or phrase, we wrote something. But we're not done. We've got to do this part now. So let's just hit every entity and fix what we need to fix. Is this a free element or a compound? That's a compound, a bunch of capital letters. We're supposed to check the subscripts. There was no prefixes, mono, di, tri, tetra, so we need to crisscross charges. What is lead's charge here? It's 2. If you look at your periodic table, you don't have a number written above lead's group. This lead has a charge of 2. There was a Roman numeral to tell us that. What is sulfate's charge? Go look at your polyatomic list. Don't guess. It's on your cheat sheet. What is sulfate's charge? It's a 2. What do we do when these numbers are the same? Nothing. So look, nothing changed. He was already written correctly. We got lucky. Let's move on then. Compound or free element? He's another compound. What is this lead's charge? 2. That's what our Roman numeral tells us, that he's got a charge of 2. What is sulfite's charge? -2. Look at your cheat sheet. The polyatomic list says that sulfite is a -2. And look, it happened again. If they're the same number, you don't crisscross anything. So even if we were dumb and forgot to go back and check them, we would have lucked out. But I hope you never count on that. Free element or compound? He's all by himself. So different set of questions. Remember, these two things don't mix whatsoever. It's either one or the other. Is oxygen diatomic? He is. So give him a 2. Let's do another. Here's our next example. The magnesium one. Magnesium and potassium oxide react to form potassium and magnesium oxide. Word for word. Magnesium. Mg. And. Plus. Come on, play along. It's fun. We can get the tennis ball out. Potassium. Okay. Oxide. Now, notice there was nothing between the potassium and the oxide, so I'm not going to put anything between my potassium and oxide. React to form is a phrase on your cheat sheet. What does react to form mean? My yield sign. Potassium and magnesium oxide. For every word, I wrote a symbol. Questions, ask them if you have them. Now let's go back and fix it. Free element or compound? Free element, he's all by himself. Is magnesium diatomic? He's not, so leave him alone. One of the most annoying things for you to do is to give everything that's diatomic a 2. You're diatomic, and you're diatomic, and you're diatomic. No, no, no. There's only 7 diatomic elements out of the 100 that are on the table. Most of them are not diatomic. Free element or compound? Compound. Multiple stuff, all right? Check the subscripts. There's no mono, di, tri, tetra, so we can just crisscross. What is potassium's predicted charge? 1. Does anybody not see where I'm getting that 1 from? What is oxygen's predicted charge? They're different this time. So I want the 1 to be oxygen's subscript, and I want the 2 to be potassium's subscript, which will look like that. Didn't really leave myself much space. Free element or compound? Is he diatomic? So leave him alone. Free element or compound? Compound, check the charges. Magnesium has an oxidation state of 2, plus 2. Oxygen has an oxidation state of 2. They're both 2s, so crisscross nothing. And then in order to balance, you can make your lists, but you would need a coefficient there. And then everything would be balanced also. What do you think of translation? Easier than stoichiometry? You try one and we'll be done. Here's our last example. right, let's see how you did. This one can be slightly different because it uses covalent instead of ionic. You won't be crisscrossing charges. You are assigning subscripts based off prefixes. If you do it in the order that we've shown so far today, I would say carbon is C, bromide is Br. There was nothing between those two words. There was no and or anything, so they're going to be a compound. Produces is a yield sign. Carbon is C, and is a plus, and bromine is Br. But what some of you probably did, just because it's more awkward when the prefixes are there, is you might have assigned these subscript as you went. Dicarbon tetrabromide. But if this is how I've shown it, then we would go back and fix it. But here I would say, well, this is a compound, so I need to make sure the subscripts are right. But this one does have prefixes. Di means 2, and tetra means 4. There is no crisscrossing when they're covalent. All right, and again, this calls upon your ability to remember things that you've already learned. Dicarbon tetrabromide produces carbon. He's a free element, but he's not diatomic, so leave him alone. Bromine is a free element, and he is diatomic, so I hope you gave him a 2. Have a good weekend.